Okay, good morning, everyone. Assalamu alaikum. This is cin2103, Lab 7, Design and Implement a VLSM Addressing Scheme. Okay, in this lab, we have two routers and two switches. We are going to meet the requirement of the subnetting given to us. Here we are going to use variable length subnet masks. Why VLSM is needed? Okay, it is used to avoid wasting IP addresses. With a VLSM, a network is subnetted and then resubnetted. That's why it's variable. Subnetted, then resubnetted. This process can be repeated multiple times to create subnets of various sizes based on the number of hosts required in each subnet. Because effective use of VLSM needs proper planning. When you start doing subnetting, you start with the network or the LAN that has the biggest number of hosts. Okay, I'll turn on the screen. It's better maybe. Yeah. So we start with the one with the biggest number of hosts. But first, this is the background of the question. Okay. This is the address that we are going to subnet, 192.168.33.128. Okay, we are using Cisco 4221 and the switch is Catalyst 2960. Okay. First, let us look at the network requirements. How many host addresses are available on a 25 network? This is /25. So how many host addresses are available? What is the equation to find that? 2 to the power of number of hosts minus 2, correct? So if it's /25, how many host bits are available remaining? No, if we say that we have /25, correct? Correct, /25. /25, meaning that we borrowed the first bit here, and then how many hosts are remaining? 2, 3, 4, 5, 6, 7. So the number of hosts equal 2 to the power of h minus 2, which is equal to the power of 7 minus 2. Can you find it in the calculator? 126. 126. Okay? Happy? What is the total number of host addresses needed in the topology diagram? What is the total number of host addresses needed in the topology diagram? Look here, we have PR1 LAN, yani network 1, 40. The second one is 2 hosts. Okay. 2. But then we have 25. We have 5, 4, and 4. Can you calculate them? 8. Yeah. 8 plus 5, 13. 13 plus 2, 15. 40, 40, 80. Okay? That's fine. How many subnets are needed in the network topology? How many subnets do we need here? We have 1 here, right? 1 here. We have, and also we have 1, 2, 3, 4. So we have total of 6. Here, look. This is 4 plus 1 plus 1. Because the link between the two routers is also a LAN. Okay? So we have 1 LAN here. Look here. We have 1 LAN here, 1 LAN here. And how many LANs here? 1, 2, 3, 4. Okay? here on the right, PR2. This is the requirement. They are assuming that they will have 4 subnets there. They don't have to put the diagram for all of them. They are just telling you that we will have 4 subnets there. And there will be four interfaces of the router used. Okay? Or four subnets. 4 subnets. Okay, now look here. What is the subnet description? What is the largest subnet, by the way? Which one has the largest number of hosts? BR1 LAN. That's the name, correct? طيب. How many IP addresses are required in the largest subnets? Yani how many hosts? 40. I need everyone to participate, please. Everyone. 40, right? What subnet mask can support that many host addresses? We need to find out. So this is the first step. So first I start with the subnet that has the largest number of hosts. This is when I want to solve a VLSM question, I start with the subnet with the largest number of hosts. Okay? Which is BR1 LAN, and it needs 40 hosts. Okay, so what's the IP address that we are subnetting? 192.168. 192.168.33.128/25. Okay, so 25, right? Yeah. So for the first one, we need 40 hosts. To get 40 hosts, how many bits I need to borrow? Or how many bits I need? No, how many bits I need to keep for the host? You are right, but how did you find out? You need to, you would either use the table or just look at here we have 1, 2, 4, 8, 16, 32, 64. If I need only 40, right? 40, so I can go up to here, صح? Then 64 صار here. So how many bits for the host? 1, 2, 3, 4, 5, 6. These are all hosts. So how many bits for the network? 2 bits. This is network, which is 192. And it will be, our subnet mask will be 255.255.255. What? 192. For the first network, which network? BR1 LAN. Okay. Let's answer all the questions. I don't want to skip anyone. So this is how many total host addresses can that subnet mask support? Which is 2 to the power of 6 minus 2. But we need only 40. We are not wasting much. Okay, so we reduce the number of wasted IP addresses. Can you subnet the 192.168.33.28/25 network to support this subnet? Yes, we have already done that. So what are the network addresses that would result from this network? Now we said this is for the first subnet, huh? What is my magic number? 64. Good. Where? Which question? أي رقم? What are the network addresses dot 128 or dot 192. طيب. ده يعني they are telling you how many subnets you get. Now we said we have two networks, two bits, right? So we will start from 192, and then if we add dot 128 dot 192, they are not the same. They are not the same numbers. You can put them under each other, no problem. How did they find out? We know how we found. We know that the first, what are the network addresses that would result from this subnetting? Okay, then you will use the first one, 192.168.33.128. I think there is So here we need to get 40 hosts. So we agreed that we need 6 bits for the host. We need 2 bits for the network. If I am using 2 bits for the network, okay, I am getting the magic number is 64, right? And we are starting from 128 because we are already starting from /25. So we will come here. So for the first LAN, I have, this is my, which I wrote here, what they call it, VR1 LAN, okay? By the way, what is the broadcast address for this LAN? 191. Very good. What is the first usable IP address? Very good. So we all agree on this. Please follow my way. This is the correct way, okay, inshallah. All right. Now we need to determine the second largest subnet. So after 40, what's the second largest one? Don't look at the answer. Try to find it yourself. Which one? 25, which is BR2. BR2. What subnet mask can support that many host addresses? 25. Again, look here. 1, 2, 4, 8, 16. What about if I take only 4 bits? Is it enough? Because this is only maximum 15. If I take this one, okay, because maximum 32. So, how many bits I need? 1, 2, 3, 4, 5. I need 5 for the host, 3 for the network. So, what? Which is /27. /27. So, فعلا, I need 3 for the network, 5 for the host. How many total host addresses that can this support? 2 to the power of number of hosts is equal to the power of h minus 2, which is equal to the power of 5. Okay, 30. Can you subnet the remaining subnet again and still support the subnet? Yes, of course. What are the network addresses that would result from this subnetting? Very good. How many bits are borrowed for the network? 3. 3. Let me just mention this point, please. 3. So again, my network now will become this, and this. I'm stopping here, صح? What is my magic number? 32. So I will come here. 192 add 32. What is it? 2, 2, 4. And this is which network? VR2 LAN. What is the, okay, what, sorry, it will be here. This is VR2 LAN. We started from here, right? VR2 LAN. All right? And this is 192.168.33.192. Okay? Just hold on 1 second. Okay. Let's delay the break until we finish this lab. It's okay? Okay. So now I know that this is my second net. What is the broadcast address for the second network? 223. Very good. What is the first usable IP address? Very good. Now let's jump to the third largest number of subnets, of hosts. So this answer is correct. Determine the third largest subnet. Which one? What is the third largest LAN? BR2 IoT. What is the number of hosts? Look here. Look on the requirement, please. Here. What do you have?
5.
Yeah, 5 hosts. Easy. This one is very easy. I need 5 hosts. To get 5 hosts, how many bits I need to borrow? Is 2 bits enough? 3 bits is enough?
Yes.
So I will take this only. Okay? 3 bits. So how many bits for the host? 3. How many bits for the network? 5. I will answer your question, but let me continue this point, okay? Before we lose the momentum. So we are borrowing 3 bits for the, we are keeping 3 bits for the hosts. How many hosts can be supported? 2 to the power of 3 minus 2, which is 6. Very good. Can you subnet? Yes, we can. What are the network addresses that would result from this subnetting? What is my magic number? 8. So this I will get 2, 3, 2, 240, 248, 1, 2, 3, 4. How many they got here? Yeah, 248. 1, 2, 3, 4. Okay? You saw how now they got this answer? So we can use the first one for the IoT, the second one for the CCTV, and the third one for the HVAC to LAN. Can you tell me why we use this? Because they are all, yani the number of hosts is within the range. This one has 5, this one has 4, this one has 4. So it's okay, correct? Are we done? No, we still need to find subnet for this link between the router and the router. You will need to do the same thing in your project, by the way. So for this one, how many hosts we need? 2. And this is, I think I gave you a hint about this before. I told you usually they use this for the link between 2 routers. And to get only 2 hosts, how many bits you need to borrow? 2. So what will be your prefix? /30 your prefix. How many network bits are remaining? 6. Okay, very good. What is the available number of hosts? 2 to the power of 2 minus 2. Are we wasting any host? So here, what's the magic number? 4. So here will be, what is the last subnet? We will add 4. 2, 5, 2. This is my 1, 2, 3. And this will be my last network. Okay? So this is BR2. This is BR2 IoT, right? This is IoT. And the second one is what? CCTV. The third one is what? C2 LAN. Okay. 1, 2, 3. Sorry?
BR1, BR2, the last one, the 248.
Yes. BR1, BR2 link. BR1, yes, very good. BR1 dash BR2 link. Okay? After the break, we will just configure these IP addresses on the router. Okay? Any